Hello everybody, Sorlian here, and welcome back to another mathematics video. And in this video, we will be looking at the interior and exterior angles of polygons. So first of all, let's head into what we mean by interior angles of polygons. So an interior angle is the angle formed inside of a polygon at the vertex by two adjacent sides. For example, if we have a shape like the triangle that you see, the interior angles in this triangle would be the angles formed by the vertex between the sides. So here would be the first interior angle, here would be the next one, and here would be the next one. So the interior angles is basically all of the angles inside of the triangle formed by the two lines. So I have a question on screen. The question says, what is the sum of the interior angles in the triangle below? So we know from our primary school knowledge and from the earlier parts of secondary school, we learned that the sum of interior angles in a triangle is 180 degrees. This means when we add up all of the angles in a triangle, we will get 180 degrees. And this applies for all the different types of triangles. So regardless of the type, as long as you add up the angles, you will get 180. So whether it's an equilateral, an isosceles, a right angle, a scalene, when you add up all of these sides, you will get 180 degrees. Now let's look at another shape and let's answer these two questions. The first one, how many sides are in the shape below? So we see that this is a rectangle, and we know in a rectangle we have four sides. So we have 1, 2, 3, 4 sides. So we have four sides, so we can say 4. And the next one, how many triangles can be formed without crossing any lines or touching any lines? So you see if we draw a straight line across here, we see 1, 2 triangles will be formed. And if we try to draw across here, you see we will touch the line and we can't form any other triangle. So we have 2 triangles. So the next question I want to ask, what is the sum of the interior angles in this 4-sided shape? So we can use our previous knowledge of the sum of the angles in a triangle being 180 degrees, and we can find this because we see we have 2 triangles. So we can simply say 180 multiplied by 2, and that will give us the sum of the angles in this 4-sided shape. So we can see 180 times 2 will give us 360 degrees. And indeed, the sum of the angles in a square, in a rectangle, in any 4-sided shape would be 360 degrees. Let's look at another one. The next question says, how many sides are in the shape below? So we see we have 1 side, 2 sides, 3 sides, 4 sides, 5 sides. So we have 5 sides. And the next question says, how many triangles can be formed without crossing any lines? So we see if we draw a line straight across here, that would give us 1 triangle. And then we see if we draw a line straight across here, that would give us another triangle, and we did not cross any sides yet. And we see we cannot form any other triangle because if we try to, we will either touch one of the lines that we drew or it will cross a line. So we see we have 1, 2, 3 triangles. So the next question would be, what is the sum of the interior angles in this 5-sided shape? So we see once again we can use our previous knowledge of the sum of the angles in a triangle being 180 degrees, and since we have 3 triangles formed here, we can say the sum of the interior angles would be 180 multiplied by 3. And we know if we multiply 180 by 3, we will get 540 degrees. The sum of the angles in a 5-sided shape would be 540 degrees because we multiplied 180 by 3 because 3 triangles were formed. So let's look at another one. So this one says, how many sides are seen in the shape below, or how many sides are in the shape below? So we have 1, 2, 3, 4, 5, 6, 7 sides in the shape. So we can say we have 7 sides. So we have 7 sides. So the next one, how many triangles can be formed without crossing any line? So let's see. So we see we can form 1 triangle here, and we can form another one here. We can also form another one here, And then we can also form another one here. Can we form any others without crossing any lines? No. So we have 1, 2, 3, 4, 5 triangles. So it's a 7-sided shape and 5 triangles can be formed. So of course, if you've been following the patterns from the previous diagrams or the previous shapes that we had, you know the next question would be, what is the sum of the external or interior angles in this 7-sided shape? So we see we have 1, 2, 3, 4, 5 triangles being formed. So we see to get the sum of the interior angles, it will be 180 because 5 triangles are formed multiplied by 5. So if we do the math and we multiply 180 by 5, you see we will get a sum of 900 degrees. And all of this was discovered simply by knowing the sum of the angles in a triangle. So I hope that you see a pattern. In this case, we had 7 sides and we multiplied the 180 by 5. And in the previous one, we had 5 sides and we multiplied the 180 by 3. And in this one, we had 4 sides and we multiplied the 180 by 2. So based on that pattern, we can conclude a few things. We can derive a few formulas. The first formula, the sum of interior angles of any polygon would be n minus 2 multiplied by 180. And of course, n would be the number of sides in the polygon. As in this example, we had 7 sides and we multiplied by 5. 7 minus 2. This one we had 5 sides and we multiplied the 180 by 3. 5 minus 2 would give you 3. This case we had 4 sides and we multiplied by 2. 4 minus 2 is 2. So the formula is n minus 2 multiplied by 180, where n is the number of sides in the polygon. So we saw that we arrived at this formula by dividing the polygon into triangles, n minus 2 triangles, where n is the number of sides. So we saw that based on the number of sides that we had, we subtract 2 from that and we should get that amount of triangles. And each triangle has a sum of 180 degrees in terms of its interior angles. So the total angle sum would be n minus 2 multiplied by 180 degrees. So let's use this knowledge now to answer a few questions. So the first question, find the sum of the interior angles in the hexagon. So we see that they gave us a number of sides would be 6. So the formula to find the sum of the interior angles, so we can say the sum of the interior angles would be equal to, so we see it's n minus 2 multiplied by 180. So in this case, we see n is 6, so it's 6 minus 2 multiplied by 180. This will give us 6 minus 2 will give us 4 multiplied by 180. This would give us 720 degrees. So of course we use the formula there. And of course if you can't remember the formula, remember you can just divide the shape into triangles and that would give you the answer. And you can use that to get the answer. And that is all there is to interior angles. You just have to remember how to derive the formula in case you may forget it. And then you can use that to answer any questions related to finding the sum of internal angles or interior angles. So now let's move on to exterior angles of polygons. So this one says, an exterior angle is the angle formed outside a polygon at the vertex by extending one of the polygon's side. So in this triangle here, we see we have 3 external angles. So the external angle is not this angle here, but is the angle formed by extending the side of the polygon. So here we extend here and this will be the external angle. So we can extend this side here and here would be the external angle, and the same thing here. We can extend here and here would be the external angle. Doesn't matter which side you go, you can even extend here, and here would be the external angle. So it doesn't matter. So as long as you extend aside, the angle formed between the vortex and the external part, that would be the external angle. So let's look at this other example. So the sum of the exterior angles of any polygon taking one pore vortex is always 360 degrees regardless of the number of sides. So it doesn't matter the type of polygon, the sum of the external angle, as long as you take one angle per vortex, you will get 360 degrees regardless of the number of sides. So in this example, we can see the external angle in this 5-sided polygon. So when we add up A, B, C, D, and E, we will get 360 degrees. So it doesn't matter the type of polygon, as long as you add all the external angles, you will get 360 as long as it's one per vortex. So in this one here, since we know the sum of the external angles will be 360 degrees, and let's say we are dealing with a regular polygon, and if you want to find the value of one of the angle, it will simply be 360 divided by n, and n would be the number of sides. So that is why we can find the size of one of the angle by dividing by the number of sides, because in a regular polygon, all of the angles are the same. So let's look at an example, a simple example. So this one says, find the measure of each exterior angle of a regular pentagon. So I've been using the words exterior and external interchangeably. External means outside, exterior means outside. So this one says, find the measure of each external angle of a regular pentagon. So regular pentagon means this shape has 5 sides. So this will simply be 360 divided by 5. So 360 divided by 5, this will simply give us 72 degrees. So we say each exterior angle of this pentagon has an angle of 72 degrees. So let's look at the relationship between the interior and external angles. For any polygon at each vortex, the interior angle plus the exterior angle will always give you 180 degrees. So this means for this vortex here would be the interior angle, and here can be the external angle. It's basically saying when we add up the interior angle and the external angle, of course, you see a straight line is formed there, you will get 180 degrees. So that's one thing we should know. And even if we were to draw the external angle at this side here, we will get the same 180 degrees because it's the same straight line. So let's look at some practice examples. So this one says, calculate the sum of the interior angles of a decagon. And we know for a decagon, it has 10 sides. So what we can do, we can check to see how many triangles can be formed from the shape, or we can use the formula. So we can say the sum of the interior angles will simply be n minus 2 multiplied by 180. So n would be 10 minus 2 multiplied by 180. And this will simply be 10 minus 2 is 8 multiplied by 180. And this will simply be 1440 degrees. And with that, this has brought me to the end of this video. And of course, I must leave some questions for you to practice on your own. So I have 3 questions here for you to do. First one, find the size of one exterior angle of a regular octagon with 8 sides. And find the sum of the interior angles of a 12-sided polygon. And the last one, find the size of each interior and external angle of a regular hexagon and a regular dodecagon. Alright, so I trust that you have a good understanding of the sum of interior and external angles of polygons. So remember, if you want to derive the formula to find the sum of angles in the sum of interior angles in a polygon, all you need to do is divide the polygon into triangles without crossing any lines. and then you multiply the number of triangles formed by 180 degrees, and that will give you the sum of the interior angles. And remember, for all polygons, the sum of the external angles would be 360 degrees. And remember, this is formed by extending the side and the angle formed between that extended side and the other side at the vortex. So I trust that you now have a good understanding, and I'll see you in the next video.